Christian Vega. So we're gonna give it like, I don't know, 30 seconds. Hi, Christian, and I'll introduce Christian and then we'll dive into his session. I'm super excited to hear it. How are you doing
I'm
today, Christian? Where are you joining us from?
fine. I'm fine. I'm very excited to talk about cybersecurity with MCP.
Awesome. Is it nighttime where you are?
I'm from Bolivia. Here is
Oh, okay.
yes,
So still afternoon for you too.
yeah, this afternoon.
Christian, I don't see your screen in the background, so you might have to reshare if you want to reshare it really quick. And
Okay,
I will dive in. Hello, everyone. Thanks for joining us again over on our MCP track. And hopefully you all just caught Jesse's demos. Those were awesome. This next session, I wanted to just kind of talk and introduce our next guest, who's Christian Vega. And what we're talking about right now is, we're looking at as AI moves from theory into hands-on security work. One of the most immediate things that is impacted is pen testing, right? And I think that that's relevant to most of our audience here today. And Christian is going to walk us through how MCP servers can extend, kind of traditional approaches, moving from CVE discovery towards automated analysis and exploit generation. He's going to give us some practical examples. Around foundational concepts all the way through advanced implementation. So I'm excited to see what Christian has in store for us. And Christian, you want to tell us a little bit? I see NetWalkers as your organization. Do you want to tell us a little bit about yourself, and then we'll dive in?
okay, of course. Um, it's Networkers is a business that make pen testings, code analysis, and some consulting IT services.
Awesome.
When I'm working around 3 years, but it's my yes.
Fantastic. Well, thank you, Christian. I'll let you jump into your MCP servers and cybersecurity. Again, everyone, put your questions over in the comments, and hopefully we'll have a couple minutes. If we can't tackle them all at the end of Christian's session, we will answer them offline and get the answers back to you. So with that, take it away, Christian.
Okay, thank you. Let's jump in. Um, okay. Well, first of all, the Model Context Protocol, or MCP, it's an emerging standard, open standard that enables artificial intelligence model to communicate seamlessly with external cybersecurity tools. Built on a JSON, RPC, and supporting transports like STDO and streamable HTTP, MCP provides a lightweight, stateless framework for interoperability. This allows to AI systems to dynamically and dynamically discover tools, understand their capabilities, and orchestrate them into automate workflows by bringing traditionally isolated tools like CV scanners, recon utilities, and exploitation frameworks. MCP eliminates fragmentation in security operations. It's a modular design that exposes capabilities like port scanning, vulnerability detection, and URL enumeration in a standardized format, making it easier to integrate diverse tools into two cohesive workflows that we will see in a bit. Um, Traditionally, pen testers manually orchestrate tools such as vulnerability scanners, reconnaissance utilities, brute force frameworks, and or exploit kits. Each step required a human judgment to interpret results and decide the next course of action, often slowly assessments and limited scalability. NCP enabled a new workflow paradigm where AI agents dynamically query available tools, evaluate their capabilities, and execute them in a context-aware sequences. For instance, an MCP-enabled AI might invoke an Nmap MCP server to conduct initial port discovery, interpret all open services, and the route of findings into vulnerability scan. MCP servers such as Nuclei, if critical CVE surface, the AI may cross-reference, exploit databases, or initiate exploit generation models where available. This level of tool orchestration empowers pen testers, especially interns or junior professionals, to perform more complete and systematic assessments while learning fundamental skills. This AI can also act as a mentor, explaining why certain tools are chosen or how findings correlate with exploitability. Moreover, MCP integrates elegantly into agentic AI workflows where autonomous decision-making improves speed, accuracy, and reproducibility. This end-to-end orchestration also benefit red teams by reducing the operational overhead associated with running numerous standalone tools. On the defensive side, MCP provides insight into tools access patterns, allowing better monitoring of the AI reasoning process and action taken, no? Like in SOC. Ultimately, MCP elevates cybersecurity by merging expert tooling with adaptive reasoning, making pen testing workflows more efficient and accessible to learners, transitioning from basic scanning toward advanced exploitation techniques. MCP architecture and pen testing workflow evolution. This architecture of MCP's ecosystem is structured around by three essential components: the MCP host, the MCP client, and one or more MCP servers. Those MCP servers can be run locally, but they require internet connection to run. The MCP host is typically in AI application environment, such as desktop assistant or agentic AI interface that require a tool access to perform complex tasks. Inside the host, beside MCP client responsive for sending and receiving a structured request via JSON RPC, managing tool discovery, and ensuring compatibility with various transfer mechanisms. The MCP server is the core element that exposes specific security tools or functions. Each server acts as a wrapper around the concrete resource, such Nmap, Mascan, FF, SQLMap, or web reconnaissance utilities. This modularization ensures that AI agents can reason about and use these tools predictably, retrieving structured output rather than requiring brick scrapping or manual interpretation. Additionally, tools capabilities are described through a schema that AI models can interpret programmatically, meaning the AI can autonomously choose not only but also how to invoke each tool. Internally, security-specific MCP servers often include mechanisms for parameter mapping, output normalization, and resource sandboxing to limit risk. This facilitates the creation of extensible pen testing pipelines that can range from simple vulnerability scans to multi-step exploiting chains. Consider a typical workflow. The MCP client requires a the MCP's right now, and the MCP server followed by exploitation or misconfiguration analysis servers, depending the outcome. The multi-layered architecture enhances efficiency and reduces inaccuracies associated with manual hands-off. The result is a structured framework enabling AI to orchestrate tools in a manner that repeatable, scalable, and transparent, ideal for both offensive and defensive cybersecurity contexts. Skill progression for MCP-based pen testing. MCP-enabled pen testing introduces students to foundational concepts before gradually transitioning into them advanced AI-driven workflows. At the basic level, the interns begin by learning core cybersecurity principles, command line fundamentals, and the purpose of reconnaissance, scanning, and enumeration tools. They also gain exposure to how MCP structures and standardizes interactions between AI applications and external tools. The intermediate stage introduces a practical tool integrations. So the professionals MCP server can use these MCP servers, wrapping well-known utilities such fuzing tools, Nmap for network mapping, Nuclei for vulnerability scanning, Nicto, or some other tools. Interpreting AI-generated output mappings can develop deeper understanding and the logic behind the tool sequence selections. In the advanced stage, they can use agentic AI workflows where AI not only runs tools but make context-aware decisions, such as identifying misconfiguration, validating exploitation, and correlating with CVEs with system architecture. Exposed to exploit generation frameworks, reasoning engines, and wide exploitation processes enhances the readiness for real-world and red team operations. Through all the stages, an emphasis is placed to ethical conduct, responsible testing boundaries, and transparent analysis. By the end, the it helped us a lot. Okay. I want to show you a demo. First, I'm thinking about developing my own tool, my own server MCP. But searching in GitHub, I found this repo, um, GitHub from HXStrike AI, and I make some code scanning. I search if this tool connects with uh, exfiltration tools have or maybe have malware. And no, this open source tool and don't have any malware or C2C um, encoded from behind. So it's safe to use it and have many tools. Uh, if we deep in the code, we can see this Hexstrike AI tool has is developed in Python and only have this few code. And I make some run I run this tool against um, DBWE. That's vulnerability application to see what I have got, and I make a short video to show. Okay. Well, um, you can run in any ID tool. I use Visual Studio Code. Where you can see the Visual Studio Code is connected with my account in the using Claude, Claude client, and run the Hexstrike in local host using a custom port. And I made a prompt saying identify and exploit all the vulnerabilities in, and I made the URL of that vulnerable application. And simple as that, uh, the the Hex Strike AI using all the vulnerabilities toolkits. This repo has connection with, as you can see, has Nmap, FO, and many tools, many pen testing tools that has the device. And the device, and I use Kali um, because they have already installed all the cybersecurity tools that I need to use, as you can see right now. And it takes 5-10 minutes and give me all the vulnerabilities in a HTML report, and I verify that the tool identify all those vulnerabilities, and that help a lot for those who are starting or in a middle term on learning pen testing, because it connects and interacts with many tools that in the primary levels we don't know. and it helps reducing time and effort um, a lot, no? Making identifying vulnerabilities. But in this case, I made an application vulnerable, like it's called DB, DBWA. And let's move forward to see when right now I'm looking at all the steps that take this tool, and let's go to the report. Okay. Okay. This tool gives me three reports, one in HTML, other in MD, and finally JSON report that we can integrate to other tools to make some more advanced analysis. Okay. The the report show me the tools have used. So in this case, use Nuclei, Burp Suite, and custom Python scripts that exploit the vulnerabilities of cross-site scripting and SQL injection, and you can audit and see which exploits that execute in the left corner, right in the chat with LLM. Obviously, this tool have limitations to the tokens I can use in the free version, but in this time I use a Claude Haiku, but you can integrate to Olama and have your own LLM to execute all the time and have no limits to use this tool. Okay. Okay. This is the report, the HTML report. And, as you can see, the script, and only with the initial prompt that I show us, you can see that they find all the vulnerabilities that have the DBW application. That makes me feel more confident and save me a lot of time. And I run this tool against a production site. And in this video, show you. Okay, I run this tool against a real production site to see how vulnerabilities they found. And when I say realize the identification of vulnerabilities and exploited, and it's my own site, because if I don't put this text, it's my own site. The LLM say to me, it's illegal. It's illegal, and I cannot do that. So if I tell him no, but it's my site, and it runs the script and all the exploitation and identification of vulnerabilities. And well, it takes 10 or 10 minutes about, and run all the initial tools, and didn't find anything. So I need to insert a more specific prompt that says, but hey, you can use a fuzzing, or you can use some dictionary or brute force to try to log in and access the system and then exploit it. And when I insert that prompt, the tool do that job for me. And I discovered that you need to be more specific with the prompt, and in the moment you need to indicate that that which tasks will do this tool. And in the end, I go jump to the end. I found 4 vulnerabilities. So, okay. Here you can see that it found some roads and information disclosure vulnerabilities, and give me all the results of the tries to exploit that site, not that production site. Okay. Um, some considerations is in this case I use Kali, but Kali doesn't have all the tools. I need to install manually Nuclei, AutoRecom, for Linux, Hydra, Foremost, Stick Hide, and some other tools, and uh, make create Python environment to don't erase or other applications that use some specific libraries. And this line is very useful if you need to execute with an alias, no, code site, because this tool Hexstrike call globally the tools, and you need to create alias for work well. Other consideration is all the code you need to run with MCP audit to be safe, and make some SAST analysis if you can find some undependency check. If you want to see some deprecated functions, you need to upgrade. Okay. Okay, and some security and best practices um, about the prompt injection risk, malicious server exploits, over-privileged configurations, transport level vulnerabilities, and some defensive strategies for a secure deployment. In this case, I run the MCP in debug because I don't want to deploy in production. Uh, and I prefer running debug and see what happened behind. And when I need, I run in debug, and after the task is finished, I turn off that MCP server. Strong authentication and encryption, continuous monitoring and auditing, and sandboxing and prompt validation. Okay, thank you. To conclude, MCP servers are changing the landscape of cybersecurity. They bridge a gap between AI and intelligence and practical execution. Thank you for your time and attention. Now I'm happy to answer any questions you may have.
Sorry, I was muted. We do have a couple questions here. Christian, this one said, I set up Hex on a web host MCP for agent use. What safety measures did I avoid a mishap?
Can you repeat the question, or maybe you can write in the stage because my.
Yeah, can you see over in the stage chat, Christian? It's Joe's question.
Oh, okay. Yeah, I have a question right now.
There, I pulled it up to the main screen.
Okay. I set up Hex with host MCP for agent use. What safety measures can we use to avoid this up? Yeah. These tools can you run in debug to see what happens, and I have and realize some tools that the HXStrike have, they are some deprecated, that right Miguel tells Pragma that is no longer being maintained. Yeah, and you can substitute because it's an open source coding, write it in Python. You can replace with a net exec, no? So I recommend you can fork that code. I have already forked it and turn on. If you have a public repo, you can activate free dependable code scanning, and these tools are available in GitHub for free, and you can enable and check what is deprecated and replace with more the newest tools like NetExec or some others.
Fantastic. So thank you so much, Christian. I really appreciate it. This was a great session. Yes, it will be on YouTube, as you asked. And I think with that, we will bring our last presenter for this session to the stage. So